Alright, again, we're back to doing some more elimination problems. If you look at your columns here, nothing falls out right away. You always want to check to see if you add things together, if things will just fall out. The next thing you want to do is look for the easiest way to come up with one of these answers. On this last problem, there was no easy way. You can't make the 3 a 4 and you can't make the 4 a 3, so we ended up flip-flopping the coefficients. Now I could do that on this problem and flip-flop these coefficients and multiply this by 10 and then multiply this one by 4, but it's going to create a lot more work. If I just recognize that sometimes I have multiples of the number, so I can make this 3 a 6 by multiplying it by a 2, and I actually want to multiply it by a negative 2, so I get a negative 6. Then I'm going to get something to fall out. So you always want to kind of look for multiples. So I'm going to multiply everything times negative 2. Now there is more than one way to do these elimination problems. It just depends on what you pick. Like I said, you could flip-flop the coefficients. You're just going to end up with a lot bigger numbers than somebody who just does it like this. So when I multiply by negative 2, I end up with a negative 8x, a negative 6y, and a negative 8. And this bottom equation just stays exactly as is. So now when I add these together, I get 2x. Those fall out and I get 0 equals 1. I'm going to divide by 2 on both sides, and I get x is 1/2. So then what I'm going to do is I'm going to go ahead and pick the first equation because it looks simpler to me, a little smaller numbers. I'm going to take and plug that in for the x. So I've got 4 times 1/2 plus 3y equals 4. So half of 4 is 2 plus 3y equals 4. I'll subtract 2 off both sides, and I get 3y equals 2. Divide by 3 on both sides, and I end up with 2/3. This is the correct answer, even though we ended up with fraction answers. That's okay. Sometimes our intersection point doesn't come out to be whole numbers exactly. In the next problem I have here, I want to go ahead and I want to say, all right, the easiest thing for me to do would be to say, okay, if only this was a negative 2, and so that's what I'm going to do, is I'm going to multiply everything times negative 2. That will be the easiest thing to do. So I get 2x plus 8y equals 10. The second one reads then negative 2x plus negative 8y equals negative 10. Well, when I do this, actually everything cancels, and so I get 0 equals 0, which means my answer is infinitely many solutions. When I get a true statement, my answer is infinitely many solutions, meaning they were really, truly the same line. This next one what I want to look at is I want to say, all right, well, these are easily getting rid of, but these I could if this was just a negative 3. So I'm going to multiply everything times negative 3. When I do that, the top one stays the same. The bottom one becomes negative 9x. I get negative 3y, and I end up with a negative 15. So when I combine my like terms, these fall out. I get negative 7x equals, this ends up being negative 7. I'll divide by negative 7 on both sides, and I get x is 1. So then what I'm going to do is I'm going to pick the second equation because it looks a little bit easier. I'm going to take and plug that back in for x, and I get 3 times 1 plus y equals 5. 3 plus y equals 5, and I'll subtract 3 off both sides, and I get y is 2. So my answer ends up being 1, 2, x, y. Again, you should be substituting these back in, checking to make sure they work. In this next problem, and this will probably be the last one I have on this section, I noticed that neither one of these is easily to get rid of, so I'm going to actually can't make the 2 a 5, I can't make the 2 a 3, so I'm going to multiply this one times 2 and this one times 3. When I do that, I end up getting a now I'm going to create the 0, so I need to change all my signs. Either that or I need to recognize to multiply by negative 2. Those create 0. Here I get negative 11y, and here I get 55. Divide by negative 11 on both sides, and I get y is negative 5. Now I may not finish this problem. The answer is negative 5 for my y value, and my x value I have to plug back in to figure out. So, again, I may not finish this because time is about to run out on my video.